So now we're going to talk specifically about microprocessors. And the basics of microprocessors are the components, how they work, and how PC microprocessor developments and features are implemented. So the external data bus, so we talked about the data bus versus the addressing bus, and you can see that these are both going to be connected to these same devices. So the processor chip has the data bus. If it's a 16-bit, it'll have 16 lines. If it's a 32-bit, it'll have 32 lines that are connected to it. And it can put data on and read data from these bus lines. And then also the bus lines will be divided, and they'll have the data bus and the addressing bus. And they're usually logically divided, but they might have all the same lines, like literally connected right next to each other. Very, very, very tiny. So you have the addressing lines and the data bus lines. They might all be represented by the bus, or it might be a data bus specifically and an address bus specifically. And so in the case of a solid state drive, they had platters in them. You might have 4 or 8 or 16 platters, depends on how it was set up. They might be double-sided, they might be single-sided, depends on how old it is. And so the data buses are incredibly fast, and the speed is limited by how fast you can switch the lines to say that I want to address memory address X. So I have to switch that in the MUX, which is the multiplexer, to tell it this is the line we want to access. So memory location 1 might be a 1 and a 1 on address bus 0, line 0 and line 1. You put power on both of those, and that's going to represent some address inside of that device. And the same thing for the processor. There's different lines that are going to tell it whether you're reading and writing and what address you're also reading and writing to and from. So it's very fast in solid state because they're just electrically connected. It happens at the speed of light. And then the MUX adds a little bit of a propagation delay, so it has to actually switch those address lines. So that communication is your latency there. But as far as addressing, once the lines are connected, all the read and writes happen at the speed of light, which is how fast electricity runs or works. So with the case of the hard drive, the old kind of hard drive where we have this device could be a solid state drive now, and with the case of the old hard drive with the platters in it, I had to figure out which address inside there I wanted to do, so we had to send it the address. That might be a serial read, it might be a parallel read, or a read and write, whatever. And then we're going to tell it we want to write such and such a data at this location. So we give it the data, and then it has to translate it and then go write it to the platter and then say, yes, it was written successfully. You know, there's a whole process there. So that's why those are so much slower than the solid state drives. The solid states are just electrically switched and it's done. So with respect to the CPU that performs operations and decodes and executes instructions, it controls computer operation completely, almost completely, and it includes transistors, integrated circuits, and microprocessors. So with respect to transistors, integrated circuits, and microprocessors, the transistors are switches, so they're either on or off. The integrated circuits perform some operation like ands and ors and some kind of logical operation. And the microprocessors can do all of the above. They can have more transistors and they can have more integrated circuits. Integrated circuits just kind of shortcut specific operations. For example, addressing a bus or something like that. They have a specific function that they do. So I give it just a short command, and then it will go and perform that command, whatever it is it's being told to do. So that's kind of logically how they're separated. A transistor is just on and off. It may provide power. There's a MOSFET, metal oxide semiconductor field effect transmitter, MOSFET. And those may provide power up to 5 volts, 12 volts, or whatever they're told to provide based on the inputs that they're receiving. So they take a line voltage and then regulate it down to some lower voltage or some specific voltage. But also the really tiny ones can just represent the ones and zeros inside the computer. So inside of a processor, you have millions and millions of those transistors. That's how they work.